हेलो। Good evening to all of you.
Good evening, ma'am.
नमस्ते सर। सर आप जुड़ चुके हैं हमारे साथ, श्रीराम सर।
हाँ, नमस्ते।
जी सर। सर बहुत बहुत धन्यवाद आपके जुड़ने के लिए।
नमस्ते।
हमारे बीच में अभी शशि मैम भी जुड़ी हुई हैं। मैम आप काफी टाइम से जुड़ी हुई हैं।
सबको मेरा नमस्कार।
नमस्कार
नमस्ते मैडम। नमस्ते।
मैम भूल रही हूँ, आप कहाँ से, बड़ौद से हैं या कहाँ से?
मैं डीएवी कॉलेज मुजफ्फरनगर।
जी जी, थैंक्स फॉर ज्वाइनिंग अस मैम। सर अभी बस थोड़ी देर में स्टार्ट करते हैं, थोड़ा सा वेट कर लेते हैं।
हाँ ठीक है, टाइम है, अभी 2-4 मिनट रुक सकते हैं।
बिल्कुल। मेरे ख्याल से शिवराज सर भी जुड़ चुके हैं। सर आप हमारे साथ मीटिंग में हैं?
हेलो
जी नमस्ते सर। गुड इवनिंग सर। शिवराज सर आप सुन पा रहे हैं?
हाँ हाँ बस एक मिनट सुनिए थोड़ा साउंड। हाँ हाँ
जी सर। सर श्रीराम सर हमारे साथ जुड़ चुके हैं, अभी स्टार्ट नहीं किया है, थोड़ा वेट कर रहे थे,
अच्छा
तो बस अभी स्टार्ट करेंगे।
ठीक है।
और मैं आप सभी को बता दूं कि श्रीराम सर हमारे आज के रिसोर्स पर्सन है, जो आज हमें डिटर्मिनेंट्स एंड इट्स एप्लीकेशन पर वैदिक मैथमेटिक्स के क्या क्या यूजेस हो सकते हैं उनके बारे में बताएंगे। और साथ ही दीप्ति जो अभी जुड़ी है, आप अपना माइक बंद कर लें। मेरे से आवाज आ रही? जी मैं आगे बढ़ाना चाहूंगी और साथ ही सबको बताना चाहूंगी डिपार्टमेंट ऑफ मैथमेटिक्स में शिवराज सर जो हेड ऑफ द डिपार्टमेंट हैं वो भी हमारे बीच में जुड़ चुके हैं। सर यहाँ पे वैदिक मैथमेटिक्स के संयोजक हैं, जिनकी वजह से यहाँ पे डिप्लोमा कोर्स ये चल रहा है। और साथ ही श्री राम सर के बारे में मैं इतने सभी लोगों को बता दूं कि जो हमारे बीच में आज इतने बड़े रिसोर्स पर्सन जुड़े हुए हैं, उनका सीवी भी उतना ही बड़ा है, लेकिन ब्रीफ करके अगर उसको बताएं तो भी लंबा समय लगता है। तो सर मैं थोड़ी सी आपके बारे में बताना चाहूंगी। डॉक्टर श्रीराम चौथाई वाले सर एमएससी मैथमेटिक्स पीएचडी बीएड हैं और रिटायर्ड लेक्चरर हैं अमोलक चंद कॉलेज यावतमल अमरावती यूनिवर्सिटी महाराष्ट्र से। सर इज अ चेयरपर्सन ऑफ नेशनल कैरिकुलम फोकस ग्रुप मैथमेटिक्स एनसीईआरटी न्यू दिल्ली एंड ऑल इंडिया कन्वीनर वैदिक गणित शिक्षा संस्कृति उत्थान्यास न्यू दिल्ली। और साथ ही सर ऑल इंडिया मेंबर हैं वैदिक गणित टीम विद्या भारती से भी। Sir is a member of Indian Society for History of Mathematics also. He is a chief faculty in Teachers Training Program of Vedic Mathematics in Art of Living International Center, Bangalore. सर ने लगभग 35 रिसर्च पेपर पब्लिश हो चुके हैं सर के पीयर रिव्यूड रिसर्च जर्नल और इंटरनेशनल और नेशनल जर्नल्स में। Sir has delivered talks on history of Indian mathematics and Vedic mathematics in national and international conferences and seminars also. He is a faculty in number of workshops conducted for students and teachers by NYAS, Vidya Bharati and Art of Living also. Sir has authored 6 books related to the subject, means Vedic mathematics. Number of popular articles published in newspapers and magazines, and he has delivered speeches on the subject in educational institutions also. Sir has delivered a talk and 10 episodes TV series on Vedic mathematics for UGC Gyan Ranjan channel. So it is a brief introduction of Shriram Chothai Wale sir. Sir, I am very थैंकफुल कि आपका सीवी पढ़ने के लिए मुझे मिला। और साथ ही साथ मैं कुछ बताना चाहूंगी कि रवि असरानी सर भी हमारे बीच में जुड़ चुके हैं। नमस्कार सर। जी अभी मैं एक बार शिवराज सर से आग्रह करूंगी कि सर आप कुछ बताएं और फिर हम श्रीराम सर का लेक्चर स्टार्ट करना चाहेंगे। शिवराज सर, सर आप कुछ बताना चाहेंगे फोर्स के बारे में या हमारी जो लेक्चर सीरीज स्टार्ट हो रही है उसके बारे में? आई थिंक सर सुन नहीं पा रहे हैं। मैं आपको बता देती हूँ, आज हमने ये एक नेशनल लेक्चर सीरीज स्टार्ट की है, जिसका पहला लेक्चर डॉक्टर श्रीराम चौथाई वाले सर ले रहे हैं और ये स्पेशली डेडिकेटेड है वैदिक मैथमेटिक्स के लिए। और इसमें हम लगातार वीकली या जैसे भी हेल्पफुल रहेगा हम लोग के लिए, उसके लिए हम लेक्चर्स कराते रहेंगे और वैदिक मैथमेटिक्स को आगे बढ़ाते रहेंगे। तो पहले लेक्चर के लिए मैं सर को इन्वाइट करना चाहूंगी, डॉक्टर श्रीराम सर। सर प्लीज वेलकम।
Okay. So, Dr. Shriram Singh Sir, Head of the Department of Mathematics, Merit University, and Dr. Sonia Gupta Madam, convener of this course, and all the August participants like Ravi Asrani ji, Roman Madam, and so many and others, which are familiar to me in some or other sense. I express my sincere gratitude for attending this lecture. Now, I will be sharing the screen, and I will request Dr. Singh Sir to switch off his video so that I can share the screen. Madam, can you see my slide?
नो सर अभी नहीं दिख रही है.
Okay, okay.
Sonia, allow sir to share the screen.
Yes, sir. Please, sir.
And due to network problem, I was not able to connect.
Okay.
ये वैदिक मैथमेटिक्स का केंद्र सर आप ही की गाइडेंस में शिक्षा संस्कृति उत्थान न्यास के साथ शुरू हुआ था और इसकी काफी लंबी जर्नी है. अब काफी आगे आ चुके हैं हम लोग. 4 बैच निकल चुके हैं और बहुत सारे बैच हमारे पूरे एडमिशन फुल रहते हैं और एडमिशन्स के लिए 4 to 5 टाइम्स एप्लीकेशंस इसमें मिलते रहे हैं. और आपको हमें पता है, बाकी लोगों के लिए हम बता दें कि वैदिक मैथमेटिक्स पे इंटरनेशनल रिसर्च जर्नल्स को भी सर की गाइडेंस में शुरू किया गया है और उसका काफ़ी काम हो चुका है. वो फाइनल स्टेज में है, रिलीज होने की स्टेज में है. और हम और सर एनसीएफ में भी मैथमेटिक्स एजुकेशन और कंप्यूटेशनल थिंकिंग ऐसे ग्रुप का पार्ट है. तो अगर किसी के कोई भी सजेशंस हैं कैरिकुलम को लेके तो वो सबमिट कर सकते हैं, हम लोग उसे रिप्रेजेंट करेंगे. और सर थैंक यू वेरी मच. मुझे पता है आप बहुत बिजी हैं, हम सब इस समय बहुत बिजी हैं. गाइडलाइंस बिल्कुल डेडलाइंस रखते हैं, इसके बाद भी आप टाइम निकाल के डिपार्टमेंट के लिए स्पेयर कर रहे हैं. आई एम वेरी मच थैंकफुल टू यू. कुछ नेटवर्क का इश्यू चल रहा है तो शायद पूरी तरह से मेरी बात नहीं आई होगी. प्लीज स्टार्ट सर.
Okay, thank you, sir. Now I will share my slide.
सर आई थिंक देयर इज सम प्रॉब्लम. अभी स्लाइड शेयर अभी हो रही है सर.
गूगल का जरा थोड़ा सा वहाँ पे दिख रहे हैं मैडम?
नहीं सर अभी स्लाइड बीच में आई थी लेकिन फिर से हट गई है.
एक सेकंड.
आई थिंक नेटवर्क प्रॉब्लम हो रही है थोड़ी।
हाँ, एक प्लस हो जाएगी शायद अभी।
जी जी।
One minute, just wait for a minute.
ओके सर, ओके, नो प्रॉब्लम। मैं इतने बताना चाहूंगी कि श्रीराम सर जो हमारे साथ जुड़े हुए हैं, उनकी बुक एक किताब है जो हम लोग यहाँ पे भी आप लोग को प्रोवाइड कराने के लिए बोलते हैं और मंगाते भी हैं। सर की बुक का जिक्र मोदी जी ने इस बार जो मन की बात एपिसोड आया था उसमें किया था, तो ये हमारे लिए बहुत ही अच्छी बात है कि सर का लेक्चर सुनने के लिए हम यहाँ पे उपस्थित हुए हैं और सर जैसी पर्सनालिटी हमारे बीच में है जो वैदिक मैथमेटिक्स को बढ़ावा देते हैं, और वैदिक ही नहीं, इंडियन मैथमेटिक्स के ऊपर सर का बहुत काम है। और मैं शिवराज सर को भी थैंक यू बोलना चाहूंगी कि सर इतने व्यस्त अपने बिजी शेड्यूल में सर यहाँ पर हमारे साथ बीच में जुड़े हुए हैं, वरना सर बहुत बिजी है इस समय। मैं जानती हूँ कि नैक तो पैनल है उसका चल रहा है, तो ये सर भी बहुत बिजी है। तो सर मैं माफी चाहती हूँ, मैंने अभी आपको ज्वाइन करने के बाद में इनवाइट किया था तो नेटवर्क इशू था शायद, तो वो कंटिन्यू नहीं हो पाया आपका।
हाँ
नाही थांबा, येतच नाही आहे, तिसरी वेळ आहे तुम्ही करतोय। टू अवॉइड इन्फिनिटी मिरर काय असतं?
डोंट शेअर युअर एंटायर स्क्रीन और ब्राउझर विंडो शेअर जस्ट अ टॅब। अच्छा, ते म्हणतायत की फक्त एक विंडो शेअर करा। म्यूट करता का आपण? म्यूट नाही आहे।
मीटिंग में हमारे साथ राकेश भाटिया सर भी जुड़ चुके हैं, जो
सर को होस्ट बनाया हुआ है मैम। सुनिए मैम, आपने श्रीराम सर को होस्ट बनाया हुआ है, तभी वो शेयर कर पाएंगे ना, नहीं तो वो शेयर नहीं कर पाएंगे।
नहीं मैम, ये गूगल मीट में ऐसी प्रॉब्लम नहीं आती है, वो जूम में रहता है। हाँ, मीट में ऐसी कोई प्रॉब्लम नहीं रहती एक्चुअली।
ओके,
इसीलिए हमने मीट को ऑप्शन लिया था, मीट का ऑप्शन, लेकिन कुछ प्रॉब्लम आ ही रही है।
ओके, ठीक है।
शेयर स्क्रीन जहाँ नीचे 3 डॉट्स हैं इसके साथ है, नीचे के 3 डॉट्स हैं।
हाँ, 3 डॉट्स में आता है।
सर हम एक काम कर सकते हैं, श्रीराम सर, सर हम एक काम कर सकते हैं क्या, आप जो आपकी स्लाइड्स हैं, ओके शायद आ गया है।
हाँ, नाउ इट इज विजिबल, राइट।
और डॉक्टर शशि शर्मा जी भी हमारे साथ हैं।
सर नमस्कार।
मेरी टीचर रही हैं मैम, और मैथमेटिक्स में बहुत कंट्रीब्यूशन है मैम का। नमस्कार मैम।
नमस्ते मैम, थैंक यू सर।
प्रेझेंटेशन कुठे आहे तुमचं?
इट्स विजिबल नाउ।
Yes, it is visible now, sir.
Yes, yes. आपल्याला त्याचं हे करावं लागेल.
क्लिक करा ना त्याच्यावर. हां, झालं.
Is it ready now?
Yes, sir.
Thank you. Sorry for the interruption. Today, my topic is determinants and applications through VM methods. 2 sutras I will be using for the purpose. Let us begin with the introduction part of this. As we know, determinant is a scalar value that is a function of entries of square matrix, and it is denoted as det A or 2 vertical bar and A, where A is a square matrix. Number of rows and columns decide the order of the determinants. It has a wide range of applications like solutions of Simultaneous linear equations, evaluation of eigenvalue of a matrix, volume of a parallelepiped and other geometrical applications, vector products, calculus of exterior differential forms, endomorphisms, and so on. The list is long. I have just mentioned 4 or 5. Today, of course, we will be dealing with two of its applications after studying how to evaluate second, third, and fourth order determinants by the Vedic Ganit Sutras. We will also learn to solve simultaneous linear equations by using determinants and some more applications of the same. The sutra which we will be using initially is Urdhva Tiryakbhyam, or vertically and crosswise, which is a very famous sutra of 16 set of sutras, and those who study Vedic mathematics know that the sutra has tremendous applications in almost all branches of Vedic Ganit. Same Urdhva Tiryak Sutra, or Urdhva Tiryakbhyam as it is properly called. Two words are there. Urdhva stands for vertical, Tiryak stands for crosswise. That Bhyam is a Vitya Vibhakti. So vertically and crosswise. Sometimes only vertical portion of the sutra is used, sometimes crosswise, and many a times both vertically and crosswise, both the parts are used. Now we move to evaluation of the second order determinant.
Sir, slides are not changing.
Slides are not changing.
Yes, sir.
Okay. Okay. Now?
Yeah, yes, sir.
Now changing?
Yes, sir. Yes, sir.
Second order determinant is two rows, two columns, four real numbers. A1, B1 first row, A2, B2 second row. And the value attached to this is obtained by a crosswise part or Tiryak part of the sutra. And the value is well known, A1 into B2 minus B1 into A2. I understand, and you will also know that it is nothing new. Just that word Tiryak is used to describe a procedure. Otherwise, it is A1 into B2 minus B1 into A2.
Sorry to interrupt you, sir.
Yes.
Sir, we can start slideshow.
अभी नई स्लाइड नहीं आई?
नहीं, स्लाइड सर बड़ी नहीं आ रही है, फुल स्क्रीन नहीं आ रही है, तो आप स्लाइड शो पे करेंगे तो फुल स्क्रीन आ जाएगी.
सर आपको ये नीचे जो कप वाला साइन है ना,
वो किया है मैंने.
अच्छा, तो
अभी वो प्रेस नहीं किया हुआ सर.
अभी
नहीं सर, अभी नहीं हुआ.
अभी उस कप पे ही आप प्रेस करिए सर.
हाँ, कप पे ही मैं प्रेस कर रहा हूँ और बहुत बार मैंने गूगल मीट पे काम किया है.
हाँ, बट ये it's not showing the slide show.
अभी ये स्लाइड दिख रही है?
स्लाइड तो दिख रही है, बट उसके साथ साथ वो लिस्ट ऑफ स्लाइड्स भी नजर आ रही है. If you press the cup, then probably the whole screen will be covered by whatever is the slide.
अभी
नहीं, वो स्लाइड शो शुरू नहीं हो रहा है.
ओके सर, देयर इज नो मैटर.
कोई बात नहीं,
कंटिन्यू कर सकते हैं, ऐसे भी कोई प्रॉब्लम नहीं सर.
We still can see, right?
This much you can see. One part of the slide is okay now?
Yes sir, we can see the slide, right?
Okay. So one example, 3, 4 and minus 2, 5, cross multiply and subtract gives the answer 23. I will not go into details of the calculations. I will just show you how the answer is there. Second example, 2, 6, 1, 1. It will be 2 minus 6. So answer is minus 4. So not at all difficult. Just we need to take a cross product and subtract. Now there are some algebraic situations involved in determinants. Just like determinant is 2x minus 1, 7, and second row minus 1, x plus 5 equal to 7. And the problem is find x. So we need to open, or we need to find the value of the determinant first, equate it with 7. That value, when we take cross product and subtraction, turns to be 2x square plus 9x minus 5 equal to 0. quadratic equation, when it is solved with the factors 2x minus 1 and x plus 5, two answers are there. X is equal to minus half and x is equal to minus 5.
Sir, this quadratic slide is not visible. Yes, now it is.
Now it is visible?
Yes. Yes, sir.
Yes, sir.
Okay. Now on the right side, we have a determinant x plus 1, 2x plus 3 and x minus 2, 3x plus 2. When we take the product of x plus 1 into 3x plus 2 plus 2x plus 3 minus x minus 2, then Urvatiryak Sutra gets applicable. 1 into 3, 3 plus 2 into 1, 2 are the coefficient of x square. They are collected. Then 2 into 1, 2, 1 into 3, 3. Then coming to right part, 2 into minus 2, minus 4, 3 into 1 plus 3. Total sum becomes 5x square plus 4x. And then the third, 1 into 2, 2, and 3 into minus 2, 6. That way we get the answer 5x square plus 4x minus 4. Now first application, as I said, is for simultaneous linear equations in two variables. We consider the equations a1x plus b1y equal to c1, purposely equal to 7, not plus c1 equal to 0, so that I can form a determinant properly. And the second equation, a2x plus b2y equal to c2. Here the sutra changes slightly, and the sutra is lopana sthapanabhyam. That is by elimination and retention. When we solve, of course, simultaneous equation, we eliminate one variable, retain one, find the value, and then with the help of the variable which we got the value, we find the value of the other variables. So step one is we eliminate x, say, and construct the equation in y as follows. That equation contains the determinant. For left hand side determinant is a determinant of coefficients a1, b1, a2, b2. We are eliminating x, so that times y equal to first column a1, a2 as it is, second column replaced by the constants c1 and c2. And we can solve this equation with determinants for y. The second step will be, now we eliminate y from the same set of equations, but while eliminating y, it will be minus 1 times the same determinant of the coefficients a1, b1, a2, b2 times x now equal to b1, b2 first and then c1, c2. And we solve for x. This is of course a, what can we say, a slightly different form of a Cramer's rule as we used to call it, where we used to calculate d, dx and dy and then take the, find the values of x and y. But here x and y too are separately found out. Of course, when x is known, we can use either equation number 1 or equation number 2 for finding the value of y directly, or 2 times we can repeat the similar steps. But one thing is to be remembered, whenever we want to eliminate y, my left hand side should start from minus 1 times the coefficient, the determinant of the coefficient. And the first column b1, b2, c1, c2. Of course, we can have the first step this much and then find the value of y. There is nothing like 1 and 2, but just to have some order, I have given the number. Any variable can be eliminated with the help of that particular sutra. This is always useful in finding the values of x and y for a given set of simultaneous equations. Just have one example, 3x minus 2y equal to minus 4 and x plus y equal to 7. We try to eliminate x first, say. So 3 minus 2 coefficients of x and y in first equation, 1 1 times y equal to 3 1 as it is, means coefficients of x, column of coefficients of x as it is, but the second column will be minus 4 and 7 will be a column of constants. That gives me 5y equal to 25 and y equal to 5. Now from 2 itself, if y equal to 5, x is equal to 2 is obvious. So we need not go for the second elimination. Sometimes it is obvious, sometimes it may not be obvious, or sometimes it may not be easy. So we may have the second step of eliminating x. Let us have next example. 3x plus 8y equal to 0. And second, 2x minus 3y equal to 5. We eliminate x by writing a determinant on the left side, 3 to 8 minus 3. I am reading it column wise. Y equal to, then column 3 to as it is. Second column replaced by 0, 5. That gives me the value y equal to minus 3 by 5. Now in this case, you can put y equal to minus 3 by 5 in 1 or 2 to find x, or go to the second step. Now eliminate y. So it will start with the same left hand side determinant with minus 1 attached to it. So that value will be same. Earlier it was minus 25, now it will be 25x. And the right hand side determinant will be 8 minus 3, 0, 5, which gives finally x is equal to 8 upon 5. Once you have a good practice of this particular way of solving, then you need not do all the calculations. By observation, you can start. Okay, now I will eliminate x. So my determinant will be minus 25 and then 40 minus, and I will get the value of y. In the second case also, my determinant will be minus 1 times minus 25 x, and the value 8 into 5 minus 3 into 0, that is 40, and I will get the value of x. So description may not be necessary, but when we want to write stepwise, it is better to write all the steps in details. In many cases where answer is expected and that too quickly, we can have the mental calculations or the minimum calculations for solving any pair of simultaneous equations in two variables. So that is one of the most important application under heading in our syllabus, Cramer's rule. We know how to operate with that Cramer's rule. Here minor changes are done so that we can quickly find the values of x and y. The Cramer's rule is also extended for three variables, equations in three variables, which we will be dealing after some time. Now we learn slightly different method for evaluation of the third order determinant. This is always a matter of calculations, and many a times it is my experience that students do many mistakes in arranging the values and then properly finding the exact value of the determinant. Here in this case, what is suggested is like this. For a determinant with 3 rows and 3 columns, A1, B1, C1, A2, B2, C2, and A3, B3, C3, we write first elements of the first row as it is. A1, B1, C1. Just look to the right part of the slide, right square of the side. A1, B1, C1. And below that A1, B1, C1, we write 3 second order determinants. How to write those second order determinant? Below A1, I will write A1, B2, A3, B3 and calculate that value, say equal to P1. Then I will write the second element of the first row, B1. Below that, I will write a second order determinant, A2, A3 and C2, C3. Not B2. So first is A2, A3, B2, B3. Second determinant is A2, A3, C2, C3. And the third determinant below C1 will be B2, B3 and C2, C3. Once this order is maintained, then the value of the determinant is very easy to find by again Urdhva-Tiryak Sutra. A1, B1, C1, P1, P2, P3 are the 6 values written one below other. Now I will apply the Urdhva-Tiryak A1 into P3 plus C1 into P1 and then minus B1 into P2. One can start writing A1 minus B1 and C1, then again we will get the same value. Both ways the sutra can be applied. But what is important and slightly different, I am not saying it is altogether different, it is slightly different. First write elements of first row A1, B1, C1 and below that 3 2-order determinants. Once we have a proper observation skill with us, after practicing 2 or 3 problems, then we need not write that second order determinant. I can directly find the value of P1 will be A2, B3 minus A3, B2. Then P2, A2, C3 minus A3, C2. And the value of P3 will be B2, C3 minus B3, C2. By observation with a good practice, and then apply a Urdhva-Tiryak Sutra with a minus sign. But if you start with A1, B1, C1, then of course it will be minus. And if you start with A1 minus B1, C1, then automatically the value will be A1, P3 plus C1, P1, 2 crosses and 1 vertical with minus sign B1, P2. Just have a, this is of course row expansion method. We will be studying the column expansion later on after this example. So determinant is 2, 1, 4, 3, 2, 0 and 6, 5 minus 2. We write the elements of first row 2, 1, 4. Below that, first determinant 3, 2, 6, 5. Value is 3. Below that one, I will write the second determinant, second order determinant of course. 3, 6 and 0 minus 2. Value is minus 6. And below 4, I will write 2, 5 and 0 minus 2 with value minus 4. And then cross, vertically crosswise. 2 into minus 4 plus 4 into 3, 2 crosses, extreme process. And 1 vertical minus 1 into minus 6. Finally, I get the value of the answer 10. So my experience is that such way of solving a determinant gives the value bit fast and correctly also, many a times. Of course, it's a matter of skill. Then we move to second example of the similar type. Find the value of x if the determinant 4xx, x minus 2, 4 and x4 minus 6 is equal to 0. Same idea works. I will write the elements of first row 4xx. Below that, I will write the values of the corresponding second order determinants. X minus 2, x4 will give me 6x. X4 and x minus 6 will give me 10. It should be 10x. And then minus 2, 4, 4 minus 6 will give me minus 4. When I crosswise multiplication and vertical multiplication, 4 into minus 4 minus 16. 6x into x will give me 6x square. And minus x into minus 10, x will give me 10x square. So 16x square equal to 16 and values of x are plus or minus 1. Now column expansion method. Similarly, similar to previous one, before we go to column expansion, row expansion method can be applied by selecting any base. So in this case, I have selected a first row. If I select a second row as my base, x minus 2, 4 say, then by ignoring the second row, I need to find the values of the corresponding determinant. Of course, answer will be same. For simplicity, we start with the best as the first row. Same idea goes for the column expansion. We write elements of first column A1, A2, A3. And now, to the right side of A1, I will put B1, C1, B2, C2, similar to previous case, and evaluate the value, say M1. Then A2, to the right side of that, I will write B1, C1, B3, C3. And then element A3, third element of the first column. To the right side of that, I will write B2, C2, B3, C3 with assumed value M1, M2 and M3 for the determinant. Again, as I said, after practice, we can have the value of M1, M2, M3 directly without writing those three determinants. And now again vertical crosswise for column A1, A2, A3 for one column, M1, M2, M3 second column. So for column, it will work like this: A1 into M3 plus A3 into M1 or M1 into A3, and again minus of vertical or horizontal way, horizontal multiplication, A2 into M2. So A1 into M3 plus A3 into M1 minus A2 M2. And I will get the value of the determinant by column expansion method. The choice is always with us whether to use a row expansion or column expansion depending on the nature of the determinant. If there are more zeros in the first column, then I will be using the first column straight away, or column expansion method. Again, I can select any column as a base. Then I need to write the values of the second order determinant accordingly, and I will get the value of the determinant. As we are aware that whatever method we use, column expansion or row expansion, value will be the same. Just one example again: 3, 5, 7, 2, 1, 1, 2, 1 minus 1, and 5, 7, 1. I will write 3, 2, 5 first elements of the first column. To the side of that, 5, 7, 1 and minus 1 give me minus 12 value. To the right of 2, I will write, it should be, there is some mistake. Okay, I will correct that. And then to the 5, I will write 1 minus 1, 7, 1. It should be 5, 7, 7, 1, not 6, 7. Possibly I made a mistake in typing. And then final value is 52. Please correct if there is any mistake while selecting the values. In this way, we can have a choice of using row expansion or column expansion method. Now, there are some properties of determinants in our course. All the properties can be very easily proved by using either a row expansion or a column expansion, or sometimes both. I will just read the properties, and one or two I will try to prove. First is the value of the determinant remains the same when rows and column in it are interchanged. So interchange of rows and columns does not affect the value of the determinant. That is what the first property says. Second, interchange of any two rows or any two columns for that matter changes the sign of the value of the determinant. That is, if one value is x, and if I interchange first and third row, the value will be minus x. That is what that property says. Third is, if in a determinant any two rows are identical, then value of the determinant is 0. Same case for columns. So once we observe that any two rows or any two columns are identical, then we need not expand the determinant. Directly we can write the value 0. Now the most important properties start. They are, if any row of the determinant is multiplied by constant k, any row, single row, then the determinant value changes k times. So it is not necessary that all the elements, say if it is a 2 by 2, and if I multiply first row by k, then original value will be k times. And of course, if I multiply first row by k and second row by k, then it will be k square times. Same case with third order determinant, or in case of first column, second column, third column, if I multiply all the 9 elements by k, then value of the determinant will be k cube times the original value. That is what is said in the properties for columns. Same properties for columns, similar. Now I move to this important property, which is very useful in evaluation of the determinant. It says that the first row is A1 plus K, B1 plus K, and C1 plus K. Second row is A2, B2, C2, and third is A3, B3, C3. Property says that this determinant can be split up into two determinants with A1, B1, C1 as first row in the first determinant and K, K, K as the first row in the second determinant, and the values are to be added with second and third row remains identical in both the determinants. Proof is not difficult at all. I have given 3 steps for the proof. You can observe that we open the determinant by our technique. A1 plus K times P3, that P3 means we know the value A2, C3, C2, A3, etc. Then C1 plus K times P1 and minus B1 plus K times P2. That P1, P2, P3 are the values of the second order determinant in the expansion. Just collect the terms A1 P3 plus C1 P3 minus B1 P2 first, and then KP3 plus KP1 minus KP2. It's minor rearrangement of the terms gives me the required values. First determinant A1 B1 C1 plus second determinant first row K K K, remaining 2 rows as it is. Not difficult to prove at all. Sometimes this property is many a times much difficult to prove in our regular courses. Just compare the proofs. You will feel that it is slightly simpler than what we used to do as a proof in the syllabus. And then comes the second next important property, when we apply on a given determinant any valid elementary row or column operations. And we use elementary row and column operation to reduce the determinant many a times. In many cases we do that. But the property tells us that application of any valid elementary row operation or column operation does not change the value of the determinant. That's why it is useful. So I select one operation R1 plus K times R2. That operation gives me on a given determinant D1, second determinant D2 with first row A1 plus K A2, B1 plus K B2, and C1 plus K C2. Again, I apply the previous property for this to split D2 into 2 parts. K common from the second, and because 2 rows are identical, it will become K times 0, and the right hand side will reduce to D1. So that way, similarly, we can split the columns also. When I apply any column operation, valid elementary column operation. That word valid is important. There are restrictions on the choice of the operations of the type Ri plus KRi, or Ri plus KRg, or Ci plus KRg. You cannot directly, R1 into R2 is not valid. Similarly, C1 into C2 is not valid. Not valid in the sense that value of the determinant will not be that same. And that's why it is not called a valid elementary row or column operation. So all other properties can be very easily proved, very elegantly proved, I must say, with the help of the technique of expansion of the determinant, either column wise or row wise. Now let me give you first application of simultaneous linear equations in 3 variables. Here earlier method is extended Sutra remains the same. Lopana sthapanabhyam by elimination and retention. For the three equations given with coefficients a1, b1, c1, constant d1, and similarly for other two equations, I eliminate x from first two equation. Once I decide to eliminate x, I will have equation in two variables. And those equations, those coefficients of y and z are to be correctly observed. First coefficient y will be a1, b1, a2, b2. Y plus a1, a2 and c1, c2 column wise z, and equal to a1, a2, d1, d2. I repeat, a1, a2 first column, b1, b2 second column times y plus a1, a2 first column, c1, c2 times z equal to a1, e2, d1, d2. Again, it's a below column or observation situation. The values of the determinants are say m1, n1 and p1. I will get the, from three variable equation, I have a two variable equation. Same procedure I will apply. I will eliminate x either from 2 or 3 or 1 or 3. That is my choice. I have selected 2 or 3. Nothing special in it, of course. Then I will get again a second equation in y and z. Because I am selecting 2 and 3, my first determinant will be a2, a3, b2, b3 times y plus a2, a3 first column, c2, c3 second column times z. And the right hand side determinant will be a2, a3, d2, d3, which values say m2, n2 and p2. One equation in terms of y and second equation in terms of y. This is a situation where I can apply the first method, two variable method, to find the value of y first or z first, whatever you like. So m1, m2, n1, n2 times z, if I eliminate y, equal to m1, m2, p1, p2. Solve for z. And the next step, eliminate z now from 4 and 5 to have the value of y. Of course, this is one order of solution. We can select any order in the sense I can select 1, 2, 2, 3 or 1, 3. Aim is first eliminate x. You can eliminate z to have the values of x and y first and then z. That is not important. Let us have example so that any doubt if is there will be clear. 2x plus 3y minus 4z equal to 3. Second is x plus 2y plus z equal to 4. And third is 2x plus y plus 6z equal to 4. I eliminate x from 1 and 2 to write a determinant 2, 1 first column, 3, 2 times y. Second determinant 2, 1 as it is, but now I will select coefficients of z in 1 and 2, minus 4 and 1, equal to 2, 1 as it is, but now I will select a constant 3 and 4. We get y plus 6z equal to 5. Similarly, I select to eliminate x from 2 and 3. So first column 1, 2, second column 2, 1, that gives minus 3 times y. Then first column 1, 2, second column 1, 6 gives me plus 4 z. And first column 1, 2, second column 4, 4, that gives me minus 4. As I said earlier, the step of writing second order determinant can be very easily overcome by observations. So after observing the equation, I can start writing eliminate x. Okay, first equation y plus 6z. Second equation minus 3y plus 4z equal to minus 4. Same continue for obtain two equations. I eliminate y first to have a value of z equal to 1 by 2. And then from z, I will get the value of y. And from y and z, I will get the value of x as minus 1 by 2. So total answer is z is equal to 1 by 2, y equal to 2, and x is equal to minus 1 by 2. Calculations are that way not important in the sense that in online procedure, it is very difficult to explain all this. And actually I have animated all the slides so that the steps will come, but unfortunately that is not working. So that may be slightly difficult to comprehend, but I am trying to explain as much details as I can. I hope you are following this. Now, there is a second application which is solved by via determinant is a problem of consistency. So there are 3 equations, but 2 variables only, not 3. And it is expected that to test whether all the 3 equations are consistent. A1x, b1y, c1, a2x plus b2y equal to c2, and a3x plus b3y equal to c3. So what we understand by consistency is all the 3 equations are satisfied by same values of x and y. Remember, whenever 2 variables and 2 equations, we are able to decide them. But whenever there are 3 or more, I have taken 3 in 2 variables, and that set of equations is said to be consistent if all the equations in that set are satisfied by same values of x and y. And a3, b3, c3, third row, if this determinant constructed out of the coefficients of the given set of 3 equations has a value 0, then we can say that the equations are consistent in the sense that all 3 are satisfied by same values of x. So we have to write a determinant, find a value. If it is equal to 0, it's okay, consistent. Otherwise, you can say that the set of equations is not consistent. Then for showing whether the values of the determinant is 0, we can always apply elementary row operations, number 1, or if any 2 rows or 2 columns are identical, then we need not expand them. Directly we will write the answer either equal to 0, or if not possible to find 0, even without expansion, we can declare that the equations are inconsistent. Let us have one example, simple one. 3x minus 4y equal to 10, first equation. 2x plus 3y equal to 1. And the third equation is x plus y equal to 1. Coefficients and constants taken together, we have a third order determinant, 3 minus 4, 10, 2, 3, 1, and 1, 1, 1. We expand it by row expansion method here. 3 minus 4, 10. Then I have directly written the values of the 3 determinants. First is 2, 3, 1, 1. Second is 2, 2, 1, 1, 1. And the third is 3, 1, 1, 1. Respective values are minus 1, 1, 2. Vertically crosswise application, 3 into 2 plus 10 into minus 1. And then minus 4 into minus 4, 1. Gives me the value 0. Because d equal to 0, given equations are consistent. If this problem is to be solved algebraically, then I need to solve first 2 equations, find a value of x and y, and then test whether the values of x and y obtained satisfy the third equation or not. But via determinant, it goes in slightly simpler manner. A problem, again, determinant we face when we deal with a problem of pair of lines or joint equation of lines. And there is a problem to test whether the given second degree non-homogeneous equation of the type ax square plus twice hxy plus by square plus 2gx plus 2fy plus c equal to 0 represents a pair of lines. There it is said that a determinant of this type ahg, hbf and gfc equal to 0. If that value turns to be 0, then we can safely declare that a given algebraic equation definitely represents a joint equation of lines or pair of lines. Not because it is a non-homogeneous equation, lines will not pass through origin. We know that much. But see the relation. Coefficient of xy is twice h, coefficient of g is twice g, and coefficient of y is twice f. 2 times h, 2 times g, 2 times f, while constructing a determinant, not accepted directly, but half of the values h, g, and f. That once we take that much care for constructing, then we will not fail in the answer. Of course, the determinant is again a special type. First row and first column identical element, AHG, AHG. FF is there and diagonal elements are ABC. That is how we remember this, writing the values. And then we will expand it either by row column expansion or first apply elementary row operations, etc. Because half values are taken, the calculations with this determinant becomes a job. For that purpose also, I will suggest the situation like this. By example, I want to do for FF. So this particular determinant is slightly difficult if I start directly expanding it either by row or column because of those fractional values. Multiplications and all those calculations become slightly difficult. So what we used to do is we try to get first row and first column, at least in this case, integer values. So we multiply first row by 2 and then multiply first column by 2. That gives me 811 and 811, a simpler situation. Then I can expand it by any method. Of course, this step is not mandatory, not necessary that you should apply this step, but such application simplifies the calculation process at least. And then, but it will be, remember it will be 4 times d on the left side because I am multiplying the first row by 2, that will become 2d. And when I multiply first column by 2, in this case at least, it will be 4d. The routine expansion gives me the answer 0. So I can declare that the equation represents a pair of lines. The last application, vector and scalar triple product. 3 vectors with unit vectors ij and k are represented with coefficients a1, a2, a3, b1, b2, b3, and c1, c2, c3. Of course, non-zero vectors. Then vector product, vector a cross vector b is defined as first row unit vectors ij, k. Second row coefficients of vector a or coefficients of ijk in vector a, a1, a2, a3. Similarly, b1, b2, b3 are selected. Now here there is no alternative. I have to take a base ijk to expand them. And then a cross b is defined. For scalar triple product, a dot p cross c is a simple 3 by 3 determinant of the coefficients of ijk in all the 3. So it is a1, a2, a3, b1, b2, b3, and c1, c2, c3. We evaluate the determinant and then we will be able to find the vector and scalar product for this. I skip the example because they are just similar to previous cases. Numericals calculations are same except the structure of arranging a determinant. Now the last part, which is slightly difficult, is expansion of 4th order determinant. Many methods are given, Jacobian determinants as they are called n by n. This is a particular case of that Jacobian determinant, but slightly different way by using Vedic sutras. For fourth order determinant, 4 row, 4 columns, A1 to D1 up to A2 to A4 to D4. The step is I divide the determinant into 2 parts by drawing a horizontal line in between second and third row. That I hope that line is visible to you. That will be the first step. I will divide that determinant row wise. Again, I can divide it, but for the matter of time, I have selected row wise. Then second step, I will find the value of 6 determinants from the lower part. What are those 6 determinants? First is, again column wise I am reading, A1, A2, B1, B2, value x1, A1, A2, C1, C2, value x2, A1, A2, D1, D2, value x3. Now, all the columns are exhausted. I come back to second column, B1, B2, C1, C2, x4, B1, B2, D1, D2, x5, say value x5, and lastly C1, C2, and D1 degree per part on the lower part y1 to y6. I write them, those values, one below another with one change. That change is, I will write the second and the fifth value minus sign. So first row will be x1 minus x2, x3, x4 as it is, then minus x5 and x6. That's enough. y1 to y6 as it is, no change in the values. And now I apply a vertical crosswise sutra for set of 6 values. First cross x1 y6, second cross minus x2 y5, third cross x3 y4, now fourth cross x4 y3, fifth cross minus x5 y2, and the last x6 y1. This is my way of imagining it. We can have like a situation like this, x1 y6 plus x6 y1, second cross minus x2 y5 and minus x5 y2, and third cross x3 y4, x4 y3. Whatever way you apply that crosswise part, whatever answer comes out of the subtraction or addition of 6 elements, where of course we can, those who are expert enough can use Samuchaya Gunitaha and all that sutras to write the addition and subtraction simultaneously and find the value. Or even by simpler first products and then addition subtraction will give me the value of the fourth order determinant. Let us have one simple example. Before you 1 2 0 minus 1 and 3 2 1 1. I break up into 2 parts the respective 6 values for the upper part. 1 3 2 1 minus 5 that come up to minus 5 0 7 0 9 and 0 again. We can check the values, not difficult at all. Then I move to the lower part of the determinant. 5 3 1 2 will give me 5 minus 5. Similarly, 8 minus 1, 3 minus 3 and 3. Obtained 6 set of 6 values, written one below another with change of sign for the second and the fifth. Second value is 0, so no question. Fifth value is 9. Initially, it will become minus 9. And then apply cross, vertically crosswise. Here vertical part is not there, only cross parts are to be considered. So 5 into minus 3, 0 into 7, as I was telling you. Then 0 into minus 3, minus 9 into 8, and 7 into 3, 0 into minus 1. Even without writing the product, I can start writing minus 15, 0, 0, minus 72, 21, and 0 to have the value minus 36 in the end. So this is one of the way by which Urdhva-Tiryak Sutra can be applied to find the value of fourth order determinant, and similar can be extended for fifth order, sixth order, and n up to Jacobian n by n order. The same problem of consistency for equations in 3 variables is attainable by constructing a fourth order determinant out of A1, B1, C1, D1 first row up to A4, B4, C4, D4 fourth row. I need to expand that determinant by the previous method. If that value becomes 0, then the set of equations in 4 equations in 3 variables are said to be consistent. Now, for non-zero value, we can declare that the equations are not consistent. So with this much about the determinants and some simple applications through 2 sutras, Urdhva-Tiryak and Lopanasthapanabhyam, I try to give you some idea how to expand and how to apply that expansion techniques in some cases. And those who are familiar with the syllabus, particularly for in graduate level, know that many times we use determinants 3 by 3 especially. 4 by 4 or higher order are lesser applicable in 2-dimensional geometry, in 3-dimensional geometry, then for eigenvalues, and many cases, even in physics, even in physical chemistry. So wherever we have a situation or wherever we need to solve a determinant, maybe second order determinant or third order, or wherever we need to solve a simultaneous equations in 2 variables or 3 variables, try to apply these techniques. It will definitely save your time. It will definitely increase the accuracy of the answer. So speed and accuracy, which are the main features of the application of Vedic Mathematics Sutra, also works for a determinant. Thanks, Merit University Department of Mathematics, particularly Dr. Singh and Sonia Gupta Madam, for inviting me for a lecture on this. I also thankful to all the esteemed participants which are present in the.
Thank you so much, sir.
If any query, any comment, I welcome.
Yes, of course. There is any query from someone?
Or any comment from anybody. Anybody can open his mic and say whatever he want to say. I welcome that.
शशि मैम, आप कुछ कहना चाहते हैं शायद?
नहीं, बहुत अच्छा और बहुत ही मतलब इंफॉर्मेटिव ये लेक्चर था. रियली बहुत हम लोगों को इससे बहुत ही अच्छा हुआ. मतलब ये लेक्चर आपने कराया, इसके लिए आपको बहुत बहुत धन्यवाद. और सर को तो धन्यवाद है ही, उन्होंने इतने सिंपल उसमें ये अपना लेक्चर दिया है. थैंक यू सो मच फॉर इनवाइटिंग मी ऑल्सो.
थैंक यू सो मच मैम. थैंक यू मैम. सर, शिवराज सर, आप प्रेजेंट हैं यहाँ पर, आप कुछ कहना चाहेंगे?
बिल्कुल, मेरी आवाज आ रही
जी.
जैसे मैम ने कहा, इट वाज वेरी मच इंफॉर्मेटिव और सर का कमांड है पूरे. हम सब सीखते हैं एवरी टाइम अबाउट ऑल दी. और थोड़ा सा और इसमें गो थ्रू जाने के बाद सर हम लेटर ऑन कर सकते हैं.
आई थिंक सर नेटवर्क प्रॉब्लम है, आपकी आवाज प्रॉपर नहीं आ पा रही है हमें।
अच्छा
जी जी।
हेलो, अब आ रही?
हाँ सर आ रही है।
कुछ नेटवर्क का इशू है आज यूनिवर्सिटी में बार बार। तो मैं ये बता रहे थे कि इसमें इस लेक्चर को और थ्रूली अंडरस्टैंड करते हुए सर से इसका कंटेंट अवेलेबल हम लोग रिक्वेस्ट करेंगे मिल जाए, और फिर इसके बाद फिर से हम डिस्कस कर सकते हैं जो भी उसके रिगार्ड के इश्यूज होंगे। तो सारे लोग अभी पूछना चाहे अभी पूछ सकते हैं, लेटर ऑन सर से डिस्कस कर सकते हैं। सारी क्वेरीज को एक साथ क्लब करके डॉक्टर सोनिया फिर से हम बात कर सकते हैं। So on behalf of Department of Mathematics, sir, we are very much thankful to you. It's only your guidance and blessing that we are running this course here. So, and it's your greatness that you are available whenever we request you. Although I know that you are very, very much busy this time. So thanks a lot. डॉक्टर सोनिया पूछ लीजिए आगे किसी का और कोई इश्यू हो।
जी जी सर। सर राकेश भाटिया सर हमारे साथ जुड़े हुए हैं। सर आप सुन पा रहे हैं? भाटिया सर?
जी सोनिया मैडम, मैं थैंक्स सारे आज सबकी आवाज सुनने को मिल गई, और श्रीराम जी ने बहुत अच्छा व्यक्त किया। हाँ, और एक डिटेल वे से इसी प्रकार से अगर हम जो है कंटेंट को प्रेजेंट करें और बुक लिखें इसी वे से, और इसका जो है एक्सरसाइज देते हुए, उसके एक्सप्लेनेशन देते हुए, तो मुझे लगता है जो लेक्चर होते हैं वो सब आप जो है इकट्ठे करके उस पर हम बुक पब्लिश कर सकते हैं इसी वजह से, है ना। तो ये हमारा जो है मैं तो कहूँगा कि जहाँ भी लेक्चर होते हैं तो इस प्रकार से हम कंटेंट को सबको हम जो है हमारी ड्यूटी होनी चाहिए, हम लिखते जाए और उसको बुक के फॉर्म में करते जाए, तभी हमारा ये कंटेंट इकट्ठा हो जाएगा। तो बहुत ही अच्छा आज प्रेजेंटेशन रही, तो आपको बहुत साधुवाद और थैंक यू वेरी मच।
बहुत बहुत धन्यवाद सर। मैं इस बीच में ये कहना चाहूंगी कि सर ने मतलब वैदिक मैथमेटिक्स को इंक्लूड करना ये बड़ी बात है। एक्चुअली हम जो पढ़ते आ रहे हैं वो एक कन्वेंशनल मैथमेटिक्स हम पढ़ते आ रहे हैं, हमने डिटरमिनेंट्स पढ़ा हुआ है, लगता है कि नहीं बहुत इजी है, लेकिन सर ने जैसे बताया वैदिक सूत्रों को कैसे प्रयोग में लाना है, लोपन स्थापनम, और सर ने बताया ऊर्ध्व त्रिज्यिभाम का जो एप्लीकेशन है वो तो वंडरफुल है। मतलब 4x4 डिटरमिनेंट को हम इतने इजीली सॉल्व कर पा रहे हैं अगर इस सूत्र से, तो ये मतलब देखने लायक है कि वैदिक गणित का प्रयोग सभी को आना चाहिए। कम से कम हम जो गणित सिखा रहे हैं या सीख रहे हैं उन सभी को आना चाहिए, जिससे कि हम आगे आने वाली पीढ़ी को ये हम दे पाए। तो मेरा तो ये मानना है। बाकी और किसी का कुछ सजेशंस हो?
मैडम 1 minute प्लीज।
जी।
There is one participant, Dr. Roman Dhawan from.
Yes sir.
I will be happy if she says anything. The reason is we will be listening to Roman Madam in next week on the same topic.
Thank you so much, sir, for asking me to speak something. It was a very, very well planned, well organized content, and the application part was also very much visible. Like I was going through the chat and there was somebody saying that is it useful for graduation students. I mean, I feel anybody who's pursuing mathematics or sciences, physics या physical sciences, तो उसके लिए determinants is a very good tool. तो उसमें 4x4 ऑर्डर तक पहुंचना और उसके डिटर्मिनेंट को सॉल्व करना, आई थिंक इट इज बियॉन्ड द वेस्टर्न मैथमेटिक्स दैट दे टीच अस, because that rule only solves first the 3-order determinant, and that too not 1-4 of them. And then, so if you compare the difficulty and the tediousness, then here the Vedic mathematics wala jo method hai, wo it is as good as a magic. नंबर 1. नंबर 2, हम इसको और आगे बढ़ा के हम इन्वर्स फाइंडिंग में भी, मैट्रिक्स इन्वर्स फाइंडिंग में भी हम इसको यूज कर सकते हैं और हमें और शॉर्टर रूट्स बनेंगे. नंबर 3, अगर प्रोग्रामिंग करते हैं बच्चे तो उसमें वो मैट्रिसेस एंड डिटर्मिनेंट्स यूज करते हैं, और जो स्टेप्स फॉलो करेंगे 4 ऑर्डर को करने के लिए, आई मीन द नंबर ऑफ स्टेप्स विल बी लेसर. So I think somewhere it will help them also कि फ्लो चार्टिंग में ये मेथड जो है बड़ा कंफर्टेबल हो जाएगा n by n डिटर्मिनेंट को सॉल्व करने में, और शायद हम कंप्यूटर को भी और फास्ट करने में मदद कर देंगे with our Vedic mathematics. I mean, I'm really thankful to sir that I have been part of the participants, and we have heard such a wonderful lecture from sir. Thank you, Sonia ma'am, you also, and thank you, Shifali sir.
Thank you so much. So anyone, any other, some queries or some suggestions from someone? I think रुचि मैम हमारे साथ अभी जुड़ी हैं. रुचि मैम, आप सुन पा रहे हैं? रुचि मैम, are you hearing me?
Yeah.
She is head of the department of
Good evening.
degree college. Yes, ma'am. Welcome मैम. आप थोड़ा लेट शायद ज्वाइन कर पाए हैं, लेकिन
हाँ, एक्चुअली हाँ थोड़ा सा बिजी थे. हाँ, आई एम सॉरी मैंने वो मिस किया क्योंकि बस एग्जाम्स की ड्यूटी वगैरह में वो चल रहा था.
नो प्रॉब्लम मैम. हम रिकॉर्डिंग है दैट इज अवेलेबल फॉर एवरीवन, सो नो प्रॉब्लम दैट एट ऑल. तो आई थिंक हमें इसको कंपाइल करना चाहिए. और मैं एक बार और थैंक्स बोलना चाहूंगी श्रीराम सर को, जो सर ने आज डिटर्मिनेंट्स में जितने भी टॉपिक्स यहाँ पे इंक्लूड किए हैं वो मतलब वेरी फ्रूटफुल टू ऑल. सर ने हमें कंसिस्टेंसी के बारे में बताया, लीनियर सिस्टम ऑफ इक्वेशंस बताई हैं, उसमें इवैल्यूएशन ऑफ 2x2, 3x3 एंड ऑल्सो 4x4 डिटर्मिनेंट्स. तो ये बहुत ही मतलब वंडरफुल लेक्चर रहा हम सभी के लिए, जिसमें वैदिक मैथमेटिक्स को इंक्लूड किया है सर ने. तो मैं आग्रह करूंगी सर से आगे भी सर हमारे साथ इसी तरह जुड़े रहें. और जो यहाँ पे डिप्लोमा कोर्स चल रहा है सर, उसमें आपकी गाइडेंस की हमें बहुत ज़रूरत है. और जो भी हमारा प्रोजेक्ट वर्क रहेगा सर, उसमें आपसे मैं आग्रह करूंगी कि आप हमेशा उसमें जुड़े रहें और यहाँ के स्टूडेंट्स को गाइड करें.
Thank you, madam. I will be there as and when necessary.
Thank you, sir. Thank you. Thank you. Thank you to
Sonia madam, I will request you to please keep a list of the participants as well, so that we also are informed about the new lectures whenever they are happening.
Yes, of course, ma'am.
Thank you. Thank you.
Thank you.
Thanks a lot, everyone. Thanks a lot, sir.
Thank you. Thank you, sir.
Thanks, everybody.
So we are ending this meeting now.
Yes.
Thank you.
Thank you. We will leave now.
Thank you. Thank you.
Thanks all.